Okay, maybe we'll start off with some introductions, and then we'll kick it off with our first of two talks for tonight. And we are very, very happy, very grateful to have first guest Ajin Abraham, world-renowned security researcher and author, creator, maintainer of nodejsscan, who's agreed to share with us some of his recent latest work on his tool. And Ajin will present for the first half of the event, and then after that, Isaac will present. Isaac is the CEO and co-founder of r2c, and he'll share some things that are new in Semgrep, as well as give a preview into things that are coming soon by showing a little bit of the roadmap. Ajin joins us from beautiful Montreal, which means he's a little bit offset in time from those of us in California, at least. So thanks, Ajin, for staying up a little bit later and sharing your work with us. I'll let you go ahead and present and take it away. In terms of kind of presentation and Q&A, we have allotted some time at the end for Q&A. Ajin, feel free to pause anytime you want to ask if there are questions throughout.
Sure. I'll just share my screen. Can you guys see my screen?
It's loading now, and I think it's coming through. I can see it now.
Yep,
Okay.
I can see it.
Awesome. Okay, so like Pablo mentioned, I'm Ajin. Today in this talk, I'm going to talk about the new version of nodejsscan and how you can use it to find insecure code patterns in your Node.js applications. So this is a quick and straightforward talk that actually give you a walkthrough of nodejsscan, its different feature, the architecture, and what are the recent changes with the tool. Feel free to jump in if you have any questions. So feel free to interrupt me and ask the questions if you have any, or you can do the QA session. We can do the QA session at the end of the talk. All right. So for those folks who actually don't know about nodejsscan, it's an open source free security tool that allows you to perform static code analysis of your Node.js web applications or standalone applications. It is actually written in Python, which might not be the ideal case, but since I am comfortable with Python, I wrote it in Python. It started out as an automation job in one of my previous role, where we had a bunch of Node.js applications, and at that particular point of time, Node.js was kind of new, and almost all of the SaaS tools that were available was actually focusing on client-side JavaScript, and none of them were focusing too much on the server-side aspect of it. So that's one main reason I wrote this tool. Initially, I just, the previous version, if you have used the previous version of nodejsscan, what I did was I actually, I created a checklist of the things that I would normally look for in a given web application. And then I tried to programmatically look for them inside the code. So I used the RE or regex module of Python to, look into the source code to find out possible insecure patterns. So Node.js as a tool, it finds insecure patterns in your Node.js code, and it can also find out vulnerabilities from your HTML templates. It actually provides you a web UI for managing identified issues, and also integrates with your CI/CD pipeline. So we have examples of GitHub Action, GitLab CI/CD, Travis, etc. I mean, pretty much you can integrate with any of the CI/CD pipeline or CI/CD build tools that you're using. Because it's a Python library at the end of the day, so you can just do a pip install and you're good to go. But throughout the talk, I'll be showing some of the demonstration on how to do that as well. And the new version also support email alerting as well as Slack alerting. So you can actually configure the tool to get alerts as and when the scan is completed.
Ajin?
Yeah.
And how long has the tool been around?
Good question. So I'm not sure about that. definitely 3 years. Maybe I have to look into the commit history. So I was actually keeping it in-house for some time before I got the permission to open source it. So probably 4 or 5 years, maybe. Yeah, I mean, it's definitely 4 or 5 years. It was, I mean, I wrote it in the beginning of my career, so that's like 5 years back. So close to
Cool.
5 years.
Thanks for sharing.
Cool. So moving on, I would also like to give you a bit intro on the architecture of the tool. The tool is written in actually in Python, and it has a nice web UI, which is convenient for most of the users. And it takes a Git URL or archived zip source code as input. So you can zip your source code, or you can provide the Git URL of your repository. And nodejsscan will perform a SAST analysis on your code and then store the results in the DB. Sorry, and you can also generate a report after the scan. And like I mentioned before, you get Slack alerts and email alerts. It's very pretty straightforward web application. It follows a very straightforward web application model. And underneath it, it's actually powered by something called libsast. So libsast is a generic SAST library, which is a kind of a wrapper for Semgrep. And it also provides some extensions to support traditional regex-based pattern matching. I would explain why we actually use that pretty much soon. So this is a library that you can, if you are interested in writing static analysis tools, and if you're comfortable with Python, even without digging too much into ASTs or looking into the internals of writing a SAS tool, you can use this library to quickly write your own SAS engine. So nodejsscan is powered by libsast, which in turn is powered by Semgrep and basic pattern matching. And I'll be using the same tool to replace the SAS core for a couple of other tools that I have previously wrote as well. So this is something that will get actively developed. And like I said, like we use both of the feature from libsast, that is Semgrep and pattern matcher. So we use Semgrep for JavaScript files, mainly because Semgrep can actually do a semantic analysis of your code. It gives you a much complex or much easier and advanced capability to look into source code for insecure code patterns. So for example, if you see the slide in the left, you can see a sample Semgrep pattern that looks for insecure deserialization in Node.js, which actually matches a code like that. And it is pretty difficult to match something similar to that using regex. I mean, you can do it, but it's not straightforward. So if I was using a regex to match this, then that would have given me a good number of false positive. And on the right side, we have pattern matcher. So we use pattern matcher to find out insecure patterns in HTML templates. The reason why we didn't go for Semgrep is because I mean, I'm not sure if Semgrep supports HTML parsing at this time, but even with that support, the problem is that the templating format is actually different. There are different templating engines that actually they have like different format of templating syntax. So if you parse it with an HTML parser, it might throw out issues with weird looking template strings. So I found that the quick and easiest way to go there and catch these issues is actually using regex. So that's why we use both pattern matcher and Semgrep. So Semgrep is used on JavaScript files for better detection, and we use the basic regex-based matching on template files. Any questions there? Okay, moving on. Okay, so enough is all of this architecture, how it works and everything. Let's take a quick demo of the tool. So if you want to run one your own, you can quickly go over to GitHub and yeah. So the easiest way to test it before deploying it yourself is using the Docker image. It's a self-contained Docker image. You can just pull the latest image and run it. You can also try it online using try in pwd. So it's a feature from Docker. Play with Docker. All you have to have is a Docker Hub account. So I'm just okay. It looks like a lot of people are actually using it at the moment, so it's out of capacity. But like in most of the normal times, you can actually use that and spin up a Docker image or Docker instance online, and then you can play with it online. Anyway, I have already set it up locally. So I have it running, and this is like the UI of nodejsscan. Like I mentioned before, you can provide a Git URL, or you can drag and drop your archive zip of source code. So let's do one thing. Let's find out a repo. So dvna, it is actually a very commonly used vulnerable Node.js application created by AppSeco. So let's do one thing. Let's take that. Yeah. So I'm copying the Git URL and clone, and that should actually perform static analysis on that particular Git repo. Yeah, so it created it did the scan and it created a report. I'll take a different example for walking through the report, just because this doesn't have like too much issues identified. So for clarity, I'm gonna look into a different scan that I did previously. So this is a very basic dashboard that gives you information about the input file, the hash of the file, the total number of files scanned, the different types of issues, total number of issues, the distribution of issues between error, warning, and info. Error being most probably like a valid issue that you actually need to fix. Warning being possible like interesting code points that you want to manually inspect and verify it's an issue or not, and info being the best practices that you might be missing in this particular application. And if you scroll down below, is it visible for you guys, or should I zoom in? I think I'll just zoom in a bit.
Yeah, that's better. Thanks.
Okay. It's looking pretty good now.
Okay, cool. So there's actually an overview of the different issue. If you want to create a report of what's the issue, what are the issues looking like, then you can use this. It gives you a graph or a chart that shows the different issues that we captured and their counts. And we actually can detect over 70 plus issues now, thanks to Semgrep. And you can also get a summary of the issues, like what's the issue name, a short description of the issue, the severity, the standards that are corresponding to this finding. So we have the OWASP top 10, as well as the corresponding CWE identifier for the issue, which is quite useful if you're trying to make a report. So you have everything at one place. Scrolling down, like these are the different issues that's identified, and scrolling down, it will actually show you different issues under each rules. So here I can see that there is a generic OS command exec, and there's a description, the severity, the OWASP and CW classification as shown before. It will also show me the file and the line numbers where the issue is present. So if I click on show code, that will show me the quick exact snippet where the issue is there. So you're actually passing request.body.url directly into exec function, which is a arbitrary OS command execution. You can also map that inside the file, so that will give you a good idea about what's the line number and the actual file with the particular vulnerability. Since this is a managed application, it allows you to mark the issues as applicable or false positive. So if you think that one of the issues is actually not applicable, like if it's a false positive, you can actually mark that. So you can click on not applicable, and that would remove this particular issue and move them to not applicable category. Similarly, if you want to move something to false positive, you can do that as well. So it's simple as a couple of clicks. And if I just scroll down a bit, you can see that it actually categorized the issues as Node.js scan JavaScript issues, as well as template issues. So since this source file didn't have any template with a vulnerability, that's why there's nothing there. Otherwise, issues would get populated here as well. And all the issues that you marked as not applicable and false positive will be shown separately for triaging. And this also lists out all the files that you just scanned, and you can quickly scan inside, I mean, search inside files, just a handy feature. So that will allow you to search for strings inside the files, if in case if you're interested in something, or if you want to verify one of the finding, etc. So it's a very basic, simple dashboard that actually gives you an information about the scan, the number of issues the number of issues identified, the summary, etc. And I mentioned about reporting. So if you have configured reporting, you can just configure reporting. For Slack, you have to provide a webhook URL. Everything is actually in the documentation. So if you go to the documentation section, it's clearly mentioned how to configure email alerts or Slack alerts. So I have already configured it for this particular app. So I can show you a Slack alert here. So this is a Slack app that just created an alert for the scan we did previously. So it found out 22 issues in 76 files. The severity description, it can quickly take you through the direct dashboard with the scan results as well. Similarly, you have email alerts, so you can configure it to send email alerts with identified issues, severity, and much similar to the Slack alert. So this is just a basic reporting of the scans. All right, now coming back to the presentation, I just want to give you a thought, like give you the difference between node.js scan with Semgrep and without Semgrep, or before Semgrep. I'm not sure if you have used node.js scan before, like the versions less than 4. So we added Semgrep support in version 4, where we actually replaced the entire static analysis engine with Semgrep. So previously, it's totally regex-based rules. Now it's more of a semantic-aware rules. We used to get a lot of false positives, so there was a lot of requirement for manual inspection initially. Now with semantic-aware rules, we have fewer false positives. So you can actually write the rules in such a way that you can, do almost accurate detection in most of the cases. Also, previously we only had lower detection rate. Now we have more accurate detections. Especially one main thing that I would like to point out was that, with Semgrep, you can even find out some of the logical issues. For example, you have a user-controlled object that results in a regular expression DOS. Things like that is quite difficult to catch using, a regex, but with Semgrep you can catch. Another useful feature is checking for equivalences. So this is a quite handy feature where if you want to look for timing attacks in Node.js code, it's more of a logical issue because you can have different variables, you can have different comparisons happening. So it's quite difficult to catch such things with regex. But with Semgrep, you have actually rules to capture even such complicated cases. So the improvement we had there was we moved from around 44 regex-based rules to around 69 to 70 semantic grep-based rules, which is actually a great thing, I would say, and the results are also much better. And previously, we used to support cross-platform because it was a simple regex, but now we support only Linux and Mac. For Windows users, you can use the Dockerized versions. But hopefully, I guess Semgrep will, in the future, will support Windows, so we can natively support Windows as well. Moving on, the DevSecOps use cases. So this is, like, so far I have talked about the web UI part, the management aspect of it. Now, if you want to run node.js scan in a DevSecOps pipeline or your CI/CD pipeline, you have a lightweight version of the same. It's called nj-scan. So nj-scan is the lightweight CLI version of node.js scan without all the web component, UI, and management or DB related thing. So you can quickly do a pip install nodejsscan in in Linux or Mac, and you can start using the CLI tool. So I'll just show you a quick demo of the tool as well. So nodejsscan. Yeah, so I already have it. I already have it installed. So pip install nodejsscan will get the tool for you, and it's quite easy and straightforward to use. So all you have to do is nodejsscan and then point to the directory where you have your source code. So I have downloaded some application. Yeah. So just zoom my screen. So you can see we are running pattern matcher as well as semantic rep. And once the scan is finished, you should be able to see the result. So here you have the different findings. So this is actually a template finding. You can see the rule ID, the description, the type here. It's a regex. So this is from pattern matcher. You have the severity, input case, the metadata, the files, the position, and what was the matched string. And if you move down, you have a different result. And this is actually from Semgrep. Similarly, you have the basic information about the issue, the files in which it's actually affected, the match position, and the line numbers, as well as the match string. So this is how you can use the CLI tool. And if you want to generate the report in JSON, you can do that as well. So we actually support JSON output as well if you use the flag JSON. And if you want to build, exit, or like if you want a non-zero exit code for warnings as well, you can do that. And if you want to look for missing security controls, you can use the missing controls flag. It's pretty straightforward and self-explanatory from the help message. Okay, so moving on, if you want to write your own tools that allows you to perform static analysis of Node.js source code, you have the Python API for the same. So with the nodejsscan, you can just import the library, specify your source code location, specify the output location, and that's it. You can programmatically access the tool to create your own security tools or integrate with your custom security tools or pipeline. So you have programmatic access as well. Now, talking a bit about build systems. So these days, you have your source code hosted in GitHub or GitLab, etc. And if you are self-hosted, you have your build systems like Travis, Circle CI, etc. So we also have some examples that you can refer to quickly integrate the tool in your CI/CD pipeline. So I have some examples with GitHub. So there is a node.js action that you can integrate with your project. So all you have to do is you have to create the workflow file that contains the configuration for node.js action, and that would do a scan of your code on all pull requests, push requests, all the pull requests or merge requests, etc., depending upon your configuration. So you can see that there's a scan that's happening, and there are different findings. And because due to the fact that there are different findings with an error severity, it actually failed the build. Similarly, you have the same thing for GitLab as well. So GitLab has CI/CD options. So it is very similar to that of GitHub. The syntax is slightly different, but you can integrate it with GitLab or any other build systems as well. Now, moving on, if you are interested in contributing to the tool, like I said, it's an open source tool. If you feel that you can improve the rule, or if you feel like you can add more rules, feel free to contribute. The new rules, I actually wrote that in around, I guess, around 3 to 4 weeks. So definitely there is a scope for QA. There might be false positives or there might be missing cases. So you can always write or modify these rules. So we keep these rules under a centralized repo under Semgrep. So here is all the rules that we use for nodejsscan and nodejsscan. These are the different rules that covers different vulnerabilities or issues. Feel free to jump into this repository and then take a look at the existing rule. see if you can actually improve these rules, or you can, if you want to add a custom rule that is not already covered, you can do that here. So the good thing about Semgrep is that it's quite easy to write the rules. You don't need to know about a different syntax, because all the rules with Semgrep are actually following similar patterns of the programming language. For example, if you want to write a Python rule, Semgrep pattern actually follows the syntax that's very close to Python. So it's very easy to get familiarized with. The learning curve is much lower. It's quite easy to jump in and start writing your own Semgrep rules. So if you haven't used this, this is the place that you should start with. The Semgrep live editor, where you can actually have, there's a lot of examples here if you want to try, but these are like simple examples, the language that you want to choose, a sample code that you want to match. If you have used regex matcher before, this is very similar to that. So you can write your own rules here, test out it here, and once you think it's ready to integrate in nodejsscan or any other tools, you can make a commit in the rules repository. Similar to that, you have if you are like good at Python, and if you want to make some contributions, or if you want to improve the tool, feel free to send pull requests to nodejsscan, njscan, or libsast. So these are the different URLs that you can check in for your open source contribution if you're interested. Finally, I would like to thank the r2c team for creating Semgrep. I think this is going to be the next generation for SaaS tools. And the biggest thing that they did, even I mean, the technology is great, but more than the technology, the biggest thing that they did is making it open source. So we might have like a lot of great commercial tools, but the accessibility to those tools are actually much limited. And I always find that if you have open source tools, eventually they actually turn out to be really, really good products. One classic example is Metasploit. So you know how good it is and how it started out. It started out as an open source project, and because of the community contribution, it turned out to be a really good product. So I'm really thankful for open sourcing Semgrep, and they are actually super supportive. Like if you want to develop your own tools, or if you want to create your own pipelines or custom requirements, they are like really active in their Slack channel, and like they're very enthusiastic about going through the issues or triaging the issues that you have raised. So I'm thankful for being super supportive during the development of the V4. I mean, we did a massive change in like around 1 to 2 months approximately, and that's actually really interesting. And that had happened because of their support. And yeah, that's it. It's a quick demonstration of the tool and the various features that the tool have. So if you have any questions, now it's time.
Super. Thank you so much, Ajin. Great that you were able to share that with us. Thanks for the kind comments at the end. It's also really helpful to get a overview of the tool, and even some things I was not aware about with the CI/CD integration and such. Let's see if there's any questions in the chat. We can give everyone a moment to type in any question that might be there. Or feel free to unmute yourself, of course, and say it verbally.
Yeah, any big plans for V5 of nodejsscan? I mean, I don't have anything in mind. So the next thing that I would do is working a bit more on QAing the rules, because I know it was a bit rushed, like 3 to 4 weeks to write rules. That is actually a very limited amount of time to create the rules. So I think the next step for me is to go through the rules and do a QA on the rules, run it using. So I think r2c provides a good platform where you can actually run the tool against like thousands of GitHub repos. So I'm going to do that and going through the issues and possibly find some bugs there, or find out an opportunity to improve the rules of nodejsscan. So that's what I have in pipeline. And we have another question: what rules are you most proud of that you ported or wrote? I mean, I am proud of everything, like big or small, they are all good. So no bias there. How does this work with TypeScript? Good question. So right now we don't have like support for TypeScript because this is actually purely focusing on JavaScript. But I think what you can do is you can actually use a transcompiler to compile it into JavaScript, and you can scan it with nodejsscan. And hopefully, like I think soon there's a support for TypeScript for Semgrep. Once that is in place, we could definitely quickly port out some of the rules to support TypeScript as well. And you don't have to worry about transcompiling or transpiling it. What's the difference between not applicable and false positive? Okay, good question. So this is something that came from one of the past requirement that we had. Like some issues are like straight away false positive. Like for example, reporting. Yeah, I mean, like the word means, it's false positive. You can mark it as false positive. But some others are actually applicable. Like for example, you have like a SHA-1 crypto, which is an issue, but it might be acceptable for your organization. It might be an accepted risk, or it might be used in a place where it's not really significant. So not applicable issues are the ones that are actually not applicable to your organization or your code, more about acceptable risk. So that's why we have given like two different clear distinction. And I'm open to change that. This is something that came out as a requirement that I had when I was initially working on that. But that's the reason for having two different sections. I think, yeah, we have more questions. When someone clicks false positive in the web UI for Node.js scan, what happens? Do you automatically add an OQA command to the file? No. So what happens is internally, we actually have a unique ID for all the scan results. So when someone creates a false positive issue, we actually move that particular ID to the false positive list. So the next time the page is reloaded, that particular ID won't be loaded under the findings. Next work, there's an example of recent. Is there an example? There are actually plenty of example apps. If you go to the Node.js scan, nJSScan repo itself, you have a unit test, and this unit test has a lot of vulnerabilities that we detect using the code. So you can just go through the unit test and take out vulnerable samples from there. Yeah, and DVNA is definitely a good example. How do you iterate on your rules and gain confidence in their quality? Yeah, so what we do is with Node.js scan, we have like a test suite that actually looks for true positives and true negatives. So that's what we use. But again, like for false positive detection, I normally I have to actually run it on a large scale of data sets. So that's why I use r2c's triaging system, where you can run the tool or the rules against a massive set of repos, and from there I can find out noisy rules or the rules that are actually causing issues. I mean, that is one real benefit. Like you can write a tool, but if you don't have like a good subset or a data set that you can run it against, it's very difficult to distinguish true positives and false positives. But with that platform, I can do that like up to a good level. So that's what I've been doing in the past weeks. Improving rules, running it again, and then improving the quality of the rules. But obviously, like for the basic true positive or false positive detection, you can use the unit test suite. So we actually support that. Does Node.js can only scan change files in CI? By default, it does not, but you can always configure your GitHub action to scan only on a pull request or scan only on a commit. So those features are actually mostly provided by Git or the build system that you have. And even if you're not using Git, there might be some there might be a way where you can actually create the difference between the head and the new commit. Like if it's not directly available in your dependency, like in your version management system, you can obviously, or you can always use that option to compare between the head and the latest commit, and then fetch out only the files in the diff and then make a scan. That can be done using some quick bash script, but by default, Node.js scan or nJS scan does not do anything about that. Okay, do you have a sense of how many bugs like command injection can be detected with Semgrep or regex? That's what I told. Like we have around 70 plus rules, and that can like possibly detect. Like you can take a look at this repo. So these are the different like vulnerabilities that we detect. I haven't created a list because this is something that I'm still working on to improve, to add more rules, etc. But for now, these are the different rule files we have. On these YAML files, we have around 70 plus rules. So it's not just these. If I go to the nodejsscan repo, you can also see the.
You're not sharing your screen if you're
Oh,
intending to.
sorry, one sec. Okay, so this is what I was referring to. So if you go to the Semgrep rules repo, you have like all the rules that's used by nodejsscan. So these are the different rules that we currently use. I don't have like a list because it is, like I said, it's actually under development. You can see changes in here, mostly called QA, new rules being added, like noisy rules being removed, etc. So I haven't created a list yet, but these are the different rules that we support. And if you want to take a look into the rules that we support for pattern matcher, we have a few template related rules as well. So most of the rules are actually semantic grep rules, and that's actually available in the rules directory. You can take a look at what are the different issues that we support. And it's actually pretty self-explanatory. You have like after the rule, you have like a description on what this rule is doing. But yes, there is no list as of now, but we can create that. Um, how many require something like data flow analysis? Yeah, so that's a good question. So a lot of things we can detect using stable patterns, but things like attacks, like things that requires multiple string concatenation, like for example XSS, or things like SQL injection, you actually need to have some kind of data flow analysis. As of now, Semgrep actually have like a good tainting support per file, so you can actually do a good level of tainting on a single file. So if you look into one of the rules, for example, let's take XSS, for example. Yeah, so these are the different patterns it actually looks for. So it looks to see if the right function is actually taking any object from the request. It can be it can be an object, or it can be an array, or it can be like other objects, like it can be a concatenation. For example, where is it? Yeah, so this can be an object, or this can be an array. So there's an array being used, as well as you can have multiple concatenation, like you can have it in a variable and use that variable somewhere else, and finally it reaches the response.send or write function. So you have like minimal tainting or data flow analysis support for these with Semgrep, but I think eventually they have a lot of things in the pipeline to support full-blown taint analysis on single files using sources, sinks, and sanitizers. So once that is in place, we can actually replace this large chunk of XSS rules with quite a few lines of code. But yeah, it's actually actively developed. I think Isaac will be talking more about that.
Yep, that's exactly right.
Yeah. So I think that's it. We don't have any more questions. Cool.
Yep. Great questions. Thank you, Ajin, so much for going through each of them and sharing your thoughts on those. And thanks again for presenting. We really appreciate it. Really grateful.
No problem.
It's really good to see you again, Ajin. If I remember correctly, the first time I met Ajin was in Montreal. I was there for a conference, and I think I was like terribly late to breakfast because I got lost or something the first time we met.
Yeah.
But I'm glad we've stayed in touch.
And just for everyone's benefit, now we'll continue with the second part of tonight's event, which is Isaac's talk. And Isaac will be sharing what's new in Semgrep and a preview of what's coming soon.
Cool. Slides coming through okay, Pablo?
Yep.
Awesome. Great. Well, hello, everybody. Ajin's presentation will be a hard act to follow, but I'll do my best. So I'm Isaac, and I'm going to be talking about what's new in Semgrep. We're going to kind of split our time actually between a recap for people who are fairly new to the tool, because I recognize some of the names in the list as people who are just getting started with it. But I'll try to provide some upfront summaries and then weave throughout. Here are the things that are new with this particular feature. And then in the last half of the presentation, we'll be talking exclusively about new things. So quick background on me. I'm one of the co-founders at r2c. If you're not familiar with r2c, we're a startup in San Francisco building a business around open source next-gen static analysis tools that we're developing, of which Semgrep is one. And the quick version of this talk is, hey, it's hard to write secure code. SaaS tools tend to be either too noisy or too slow for a lot of modern development workflows, and you have tools like grep, but they don't tend to be expressive enough. So if you wanted something that was very fast, code aware, flexible, maybe made a few judicious program analysis compromises, Semgrep is what you might be looking for. So the idea is to make it easy to enforce organization-specific code patterns and best practices, find security bugs and variants, automate code review on PRs super quickly. So the changelog, I was actually prepping for this talk, the changelog is kind of dizzying. We're actually only going to have a chance to talk about 6 things, and I wasn't able to fit all of the things in the slide just since the start of May to now. You can always go back and look at the changelog. It's very detailed. We release every Tuesday, in case you haven't caught that already. So I'll come back to this slide, but this is sort of a preview for those who are already familiar with Semgrep but are curious about what's been done recently. So talk outline, first part, we're going to go into a short Semgrep intro. Second part, we'll talk about the registry, integrations, community. If you were to build your own tool like Ajin's, what might that look like? What are the hook points? What have other people been doing? And then we'll talk about the new features in the core engine. So normally I talk a lot about like, hey, regex versus like a semantic grep type tool. Ajin already covered a lot of that. The general thought it's that it's possible to grep for code. It's possible to grep for HTML. There's actually a famous Stack Overflow answer about the problems with this. But in general, like it solves some problems, it creates new problems. And the whole idea with Semgrep is that fundamentally the issue here is that code is really not designed to be thought of as a string. It's designed to be thought of as a tree. The first thing you'll do in a compiler's class or with any kind of interpreter is you'll parse the code from a string representation into a tree-like representation. And although there are a lot of tools out there that can do that, both in the open source world and in the SaaS world, they tend to have some distinct disadvantages. So like dlint, bandit, flake8, ESLint, well, nodejsscan I think was on this list before it had actually ported to using Semgrep, tend to use a domain-specific representation. So for instance, these Python tools are all going to lift things into the Python AST built-in module. And if you're going to use that effectively, you need to become an expert in how tokens are represented internally for Python, and then you need to do that again for Ruby if you're using something like Rubocop. You also need a decent amount of programming language expertise. So if there are 4 ways to call a function in Ruby, you need to be able to handle all of those idioms because most languages have more than one way to do it. So actually on the right, prior to the development of Semgrep, no surprise to some of you, we were working on a lot of ESLint, flake8 plugins for each of these specific languages. So we've written a lot of them and we kind of know how difficult it can be. But if you've never seen one of them before, this is basically what a lot of the code looks like. You're interacting with these AST elements. And you're just trying to get a sense for, hey, like I need to manipulate these values. I'm going to have to bring my own tools to do any kind of data flow or other inference on top of the AST. And of course, there are plenty of commercial SaaS tools. They tend to be more on the expensive side, but potentially more important for our talk, they're difficult to tune. So there are not many of those commercial SaaS tools that come designed to let you as the end user open them up and really fundamentally alter the queries that are being written inside them. So Semgrep's idea is just like, hey, you should be able to specify a query that looks very much like source code. So if you were looking for set cookie calls in Flask, you would just fully qualify the method name, and you would put some sort of wildcard inside what goes in the function arguments. And the complexity spectrum is basically try to get the best features from Sass with the speed, portability, and kind of ease of iteration that you have with grep. So it's a place somewhat in between the two on a complexity curve. And like if you're just dropping in for the first time, you can get started immediately. If you're on OS X with a brew install, there are instructions on the GitHub repo for other operating systems. And that query that we just wrote can be expressed exactly like this. This is a free open source product. The first version of Semgrep was written at Facebook. And Johan Padalio, who was the first PI hire at Facebook, actually joined us at r2c last year. If you're familiar with the Coccinelle project, which was a semantic patch and refactoring library for the Linux kernel, Johan contributed to that while he was doing his PhD at INRIA back in the day. So semgrep.dev is where you would want to get started. That's just a redirect to our GitHub repository. And without further ado, I'm going to jump into some tutorials that basically show you exactly how it works. For these tutorials, we're going to use the live editor. So the live editor is just a front end to the local Semgrep install. If you click on this button and then you click run locally, you can see how to use this for a local Semgrep install, or if you are using it via Docker. We did actually have a user successfully start using this on Windows via the Windows subsystem for Linux last week. So hopefully we're making progress on that, Ajin. And just to highlight, okay, if you have Semgrep versus grep, what are the differences between the two? We're going to copy this snippet of code looking for, written in JavaScript, a function named exec, which of course is going to turn a string into arbitrary code. And we're just going to say, I don't care if there are 0 or more arguments to this exec function. I just want to find all of them. So if we were grepping for this, our grep would have picked up, like this commented code. It would have picked up this code in the string. It would have probably picked up something, if we said like some exec, foo. But Semgrep is not, limited by any of these grep constructs. So kind of out of the box, we see the general pattern. We're going to have the code here. We're going to, most of the time, just copy and paste the code into the pattern box, and then use this to get a sense for what the matches are. So super basic example. Feel free to chat questions or interrupt me if I'm moving too fast. But coming back to the set cookie example, so I'd like to kind of drill into that. And if you've never used the pattern syntax before, this is going to get a little bit more interesting quickly. So one of the things that we added in the early days of Semgrep is the ability to compose basically Boolean range operators across different patterns. So the most basic pattern that we can imagine for this snippet is flask.response.setCookie _. This is what we just mentioned in the slides a minute ago. And if I run this, you can see that even though we're saying from Flask import responses R, so we've got an import alias here, we're still successfully matching r.setCookie across a couple different instances here. And the intuition is, maybe I'm a security engineer at my company. I know that this is the Flask framework. There are a couple flags. In particular, I care that secure equals true is set and HTTP only equals true is set. This is going to make sure that the cookie is only accessible, or that the cookie is not accessible to JavaScript, and then that the cookie is sent over HTTPS. So I can take this pattern here, which we see is matching these first two cases where we do want to trigger it, but it's also matching the secure cookie invocation here. And basically what I'll do is I'll say, okay, I want to match this general pattern, but not the pattern where secure equals true and HTTP only true are set. So I'll put a comma, I'll put these keyword arguments, and then I'll put another ... after that. So if I run this, we should see that this third instance is filtered out, and the first two are actually triggered on. So this is the sort of iterative loop that Ajin and others have been going through to develop the rules. I can supply a helpful message to the user. I can give it a little ID. And now you can see these popping up over here. I can run this locally just fine. I can set this config file to be part of the configuration for when somebody runs it on a repo. We've added some nifty new stuff that makes it really easy to go in and just add it to CI. So the CI scripts for a couple of popular CI systems, and it's actually created a little short URL snippet for this as part of clicking that button, which is pretty nifty. So again, fairly basic example. Let's see something a little more interesting. So here is an example with a Go function. So we've got this Go listen and serve, HTTP listen and serve. Turns out in Go, there's actually a listen and serve TLS, and maybe we would prefer that the developer do that instead. So we'll put as a single pattern, HTTP listen and serve. We'll put a ... there. And again, it's correctly sort of inferring that HTTP came from the net HTTP module, and it's triggering on this line of code. So now we've switched from the world of Python and JavaScript to Golang. We're going to come back to this example later, actually, because one of the new features that we've added is the ability to specify an autofix. So what we'd like to say is, hey, you should be really using a listen and serve TLS function, which is going to take some additional arguments. And we would like to suggest that to the user, and then just be able to click a button and like suddenly have the auto-fixed code appear there. So far we've seen this ... operator quite a bit, and being able to compose patterns together, filter out some cases, have other cases. There's another feature which is pretty nifty, which is the ability to basically specify variables as capturing groups without having to know their names. So in Semgrep parlance, these are called meta variables. The ... ellipsis operator and the meta variables are actually the only two really significant syntax changes. Pretty much everything else just looks like source code. So in this example, if we rename foo2 to something else, this is not going to match. But if the left-hand side and the right-hand side are identical, even if it's, like let's say a complicated expression, like a.b plus 3, it's still going to match just fine. We can use this to do other things. So we can say like if some condition, let's just say what if the if and the else block are the same variable. And in this case, even if I change this to be something else, we're matching this instance because the true and the false conditions of this, even if we like add some other statement here, are both going to match the grouped meta variable, although this is not valid Python for some reason. So let's look at an example that combines both of these things. Here we've got something, and this goes to a question that was asked a minute ago, which is a little bit more intricate around, we've got, like something that is flowing from input to the function, flowing out to the output. So we would like to make sure that file name, which in this case comes from the user provided argument to the GET request, does not flow out to send file. So the first thing we'll do is, let's just write a query that's going to match send file. So I'm going to say flask.sendfile ... You can see that matches this here. And then what I want to do is I want to specify file name as actually one of the arguments. I'll use it as a meta variable. That should still match just fine. That's great. And then the next thing I want to do is I want to say, well, actually, I want to only trigger on this when it happens inside a function named getFile. And I don't actually care what happens in between this. I just care about file name here being some sort of input to the function, and then this flowing back out like that. So if I run this, we trigger on this function. And actually, there's a little bit more that I could do here. I could specifically say I could use the decorator in my query to say like, oh, only if this is actually like a route. So then we know that for sure this is something that is coming from user supplied input. Does this trigger? But just to give you the idea of where the tool is going, this is a very basic kind of like tracking from the argument to some sort of output in the function example. So let's look at something that's even more tricky. This is actually an example of something that, when you buy a commercial static analysis product, typically it has to ship with a collection of rules that are suitable for every customer. And only by paying that company a lot of money are you able to get customized rules that are specific to your organization. So let's imagine that we're a financial trading application and we've got a fairly basic rule that every transaction has to be verified before it gets made. So we want verify transaction to be called on any object before we pass it to make transaction. So this example would be okay. We've got verify transaction and make transaction. This example would not be okay. We're just calling make transaction. This example would also not be okay. Make transaction comes before verify transaction. And the like pattern here, so you can see just like before, we've got a pattern not, so we're going to filter out this case, and then a pattern, which is our positive selector. So the positive selector is grabbing make transaction. The negative selector is filtering out all the cases where verify transaction happens before make transaction. And this seems to be working pretty well in our examples, although there's actually one here that seems wrong. Verify transaction is being called with other, and then make transaction is being called with T. So if you've been following along so far, this is sort of the final tutorial. And the way to fix this is to, rather than saying, hey, we don't care 0 or 1 arguments to these functions, we'll specify a meta variable and that it has to be the exact same variable between verify and make transaction, which should result in this case on line 53, suddenly triggering, which it does. So that's great. The other thing to note here, which is pretty cool, is that you can use these meta variables in the message that goes out. So you can see here, I'm saying in method, and then in the output, the method name is actually being specified on the output. So that's really handy for making things more obvious for developers. We're not gonna have time to go over the recap, but the general idea here is really you should be able to learn all there is to know about Semgrep in about 5 minutes. You've got code equivalences, which just kind of happen automatically. You've got the ellipsis operator, which will match arguments, parameters, characters, or statements. And you've got these meta variables, which you can use to match both expressions, statements, and names in all sorts of clever and creative ways, because Semgrep enforces this inequality constraint on meta variables for you automatically. So we'll post the slides. Feel free to go back to that. But now I'd like to get in some of the stuff that's happened that's new. So the part 2 of the presentation has to do with the registry. And the registry is actually, it sounds very fancy. In reality, it's just a Git repository. So if you brew install Semgrep, when you run it with the -config argument, you can just point that at a folder of YAML files. And we have a registry on Semgrep Live, which is basically just a pretty front end to the Semgrep rules repository. It actually includes rules from some other repositories. So for example, Ajin's rules, which you saw under Semgrep/nodejsscan rules, are also included in the registry. And I guess Drew was just showing me some stats. We have, I think, quintupled the number of rules in the registry since our last meetup. So we're at like somewhere between 400 and 500 right now, thanks to the awesome contributions from people like Ajin, as well as other people from the Python and JavaScript, both development and security research communities, which is super cool. The registry basically has some nice display stuff. So it'll show your message, it'll show any tags. One of the features that Ajin requested and helped us design was being able to specify arbitrary tags on the repositories. So if you specify things like the CWE tag or the OWASP tag, that lets us generate cool graphs like this. So, actually, not even all r2c people, we've had a bunch of other community people help us contribute coverage for OWASP top 10 across the languages that were first supported inside Semgrep. And I teased this a minute ago with the integrations, but the whole idea here is, hey, it should be really easy to enforce secure defaults and frameworks at CI time. It should be easy to add it to CI, either as a Docker container or a Linux binary. Semgrep is now a statically linked Linux binary, which is awesome. And it has JSON output, so it's really easy to kind of pull that into any kind of other tool. One of the things which is pretty cool, if I click over to the registry, so you can basically search through all of the rules. For example, if you want to just browse through in a nicer UI than GitHub, the node.jsscan rules, we can filter down to those and kind of see, oh, here are the things that are actually going on. And then you can actually, if you want to edit them, just click edit in live editor, and we'll pop into loading the pattern here, as well as an example snippet that you can go back and edit. We've also put some of them into packs. So it's not nearly as full featured as something like node.jsscan, but for instance, many of the Java rules for find sec bugs, which is a tool that runs on compiled Java binaries, we've actually ported into just a pack of Semgrep rules. So you can go and just run --config semgrep.live/p find sec bugs, and that will run all of the rules in this check pack on your local Java repository. So that's pretty cool. We've had a lot of fun, and a lot of people have found it really useful to be able to just kind of grab a predefined collection of rules and start running them in CI very quickly. The other things that are going on, I'd like to, that was sort of the community side. On the integration side, we talked last time about our work to make Semgrep really, really deeply scriptable. So for instance, there is a pattern where Python if you refer to the docs, these Boolean composition keys in the YAML for being able to combine and merge multiple queries have gotten pretty deep. So it's possible to basically put your arbitrary Python code inside here. If you're familiar with a tool which is basically the successor to Bandit named dlint, originally developed by a fellow at Duo Security, Matt Schweger, who ended up joining our team earlier this year. He's actually been using this pattern-aware Python functionality to port like even the very, very detailed logic of the tool. So like some things, for example, regular expression denial of service, require hundreds of lines of Python to analyze in detail and figure out like, oh, is this something that's exploitable or not? But it's actually now possible to just plug that directly into Semgrep, which is super cool. The other thing that Ajin mentioned earlier is that r2c has a platform that makes it easy to scale up and run on tons and tons of repos. So for instance, earlier, I showed you an example where we had $x equals $x. One of the interesting things about Semgrep is as opposed to a like traditional static analysis tool where it's trying to like make everything perfect across every line of code that's possibly written, is that Semgrep is much more about fast iteration. So we had this idea, oh hey, if the left-hand side and the right-hand side of something are actually equal, that might find real bugs in code. And then we ran it on a couple of thousand repositories, and we quickly discovered that most of those conditions were actually happening inside asserts or EQ methods. So we just added a few, like a few conditions that were like, yeah, if this is in an assert true, assert false, we don't care. And with 2 rounds of iteration on this original rule, we were able to really quickly come to some very, very interesting bugs. So I just clicked on one in Scapy. I'll show you one in Apache libcloud as well. Here, the developer meant to use node_id and actually used node.id instead on both the left and right-hand sides of the equality operator. So this is always going to return true. All the nodes are going to be there, and then the first node is going to be returned. Here's an example in Scapy where identifier and identifier are compared directly as well, which is pretty fun. So semgrep.dev has been updated with a lot more documentation on the configuration syntax. Another thing that I think Ajin mentioned is that it's also available as a Python library. So it's pip installable if you want to use it as a dependency to your tool, which is super nifty. And then although the program analysis core of Semgrep is written in OCaml, which is where all the parsing and heavy lifting happens, the command line wrapper and actually the interface for the YAML files and the operators that you see here on the right are actually implemented in Python. So that's why it's easy to have like an embedded Python interpreter executing arbitrary code from the rules. But we find that there are more people capable of writing Python than OCaml. So if you had an idea for like an interesting operator, it's actually not that hard to contribute it into the core, which is pretty cool. So in terms of language support, this document is a little out of date because we actually just shipped support for OCaml and JSON in the current release of Semgrep. But TypeScript, PHP, and Ruby have been on a roadmap for a long time. We expect TypeScript and Ruby to land in July. And we haven't seen a lot of demand for PHP yet, so we're kind of waiting for somebody to ask before we explicitly ship that. Nothing has changed in the license, but just to emphasize that Semgrep is LGPL, which is pretty awesome. Makes it very easy to develop integrations. And now to get into the really fun part. So what is new in Semgrep? So you may have noticed we renamed sgrep, which was the original name of the tool from its time at Facebook, to Semgrep. It turned out there was actually an existing structured grep tool from like the late 90s that had the package name. So we wanted to make sure the domain name and the package name could match. We made it available on Brew. I already mentioned OCaml and JSON. There's also now inline whitelisting capabilities. So if you want to use a no, # no QA flag, that's pretty easy to do. The git ignores are honored by default. So if you're running it in a Git project, it won't analyze, like your ignored node modules folder, for instance. There's a pattern regex, which allows you to combine Semgrep patterns and regexes in the same YAML file, which is super cool. There's a serif output format if you're exporting to a tool that expects the serif, sort of static analysis interchange format. It also became parallel by default. and then a couple things that will require some more explanation. So I'm going to go over 6 of these right now, but deep expression matching, being able to match on types, and then having a step-by-step debugger for a composed pattern. So the first thing is user-defined equivalences. The general idea here is, hey, let's say that I have x equals y. For some patterns, that should be the same as y equals x. This isn't true, for all objects, so it wouldn't necessarily make sense to have inside a, like enabled in the engine by default, which is actually what it used to be. But I can specify an equivalences key with the equivalence here. And then I wrote a rule like x equals y, and that's matching both this example where a equals hello and the example where hello equals a. So that's pretty cool. This is a really powerful thing that, I wish it had been available earlier, because some of the examples that you saw from Ajin could have really benefited from it. We found that, we were able to reduce many of the rules by an order of magnitude by making available to the user the equivalences that are currently built in to the Semgrep engine. The next feature I spoiled a bit if you were paying attention, but there's now support for explicitly specifying types inside the patterns, and for the engine to be able to honor the usage of those types. So if you look closely here, you'll see that we're still using the meta variable x, but then we're explicitly saying that the type of y must be string. And in this Java example, we've got string a, int b. We are matching the first one, but not the second one. So this is an extremely useful capability to be able to increase the precision of rules. The type inference is fairly limited now, but is actually expanding dramatically. Somewhat incredibly, this is actually an intern project. So our intern Emma is amazing and has knocked this out already in her summer internship. So if you see her on the community Slack, make sure to give her a shout out for it. The next thing is kind of interesting actually to talk about. We improved a bunch of performance stuff. So Semgrep now goes as fast as 500,000 lines of code per second. On some languages, it'll slow down if you're specifying a bunch of rules in parallel. But we also added support for JSON and OCaml. These were fairly easy as there was already a lot of Semgrep support in them. But I wanted to highlight that there's a really cool project currently maintained by GitHub named TreeSitter, which is all about automatically building high performance parsers for a whole bunch of languages. So when the Ruby and TypeScript support land, they will actually be building on top of bindings that we've built to TreeSitter, which should make it basically for any of the languages on this list much easier. It was already fairly easy, just a couple of weeks to add support for a language, but very easy to add support for any of these languages into the Semgrep core. So just to give you a sense of what the JSON support looks like, here is an AWS IAM policy. And you can see here I've specified the resource key is ... And then I'm actually using an OCaml regex, which is something that is maybe a little bit difficult to find the documentation for, but it's matching here on this string inside. Oh, no, it's matching here on these two strings inside resource. If I change this, for instance, to a B rather than an A, it's no longer going to match the inside of this JSON object. So that's pretty cool. We look forward to seeing what people will do with this. It's a pretty new capability, but it's built on the JSON parser, which comes from the JavaScript parser actually. So it's very robust. And there's a lot that can be done in terms of, so many configuration files are JSON now. So we're really excited to see where the community takes that. So 4 out of 6. Deep expression matching is something that was actually mentioned in Ajin's talk, but has not been explicitly discussed. So one of the things that can be really useful is to say, hey, I don't really care how some object is used inside this call to the function. I just know that somewhere in the expression this should occur. So for instance, like traditionally, if I just had redirect with request.args get foo, this would work fine, even without this special ... bracket syntax. But if I nest it, whoops, let me reload that. If I nest it deep down inside some of these calls with some function, like it could be some function, it's making a call to A, is making a call to B, I'm going to have a really hard time specifying every variation of that inside a Semgrep pattern. So this operator, the bracket or less than sign dot 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 basically lets you say this sub-expression just must occur somewhere inside the parent expression. And again, it's designed to really help crack down on how many variations you need to write in order to express what you're really trying to find inside the code base. The next thing that we added, which was actually a pretty easy contribution just on the Python side, is the ability to compose Semgrep expressions with generic regular expressions. So here we're using pattern inside to basically say, hey, I want to see anywhere somebody is instantiating a Boto3 client with a hard-coded host. And then we're composing that with pattern regex to say, yep, and then I want to check inside whatever the range returned by this expression was. Do I see something that looks like a local, internal IP address? In conjunction with this, we shipped a feature which is about to become a little more prominent, but is currently hidden under the advanced options, which allows us to say show step-by-step rule evaluation. So for this one, if I turn that on, you'll see that the initial first pattern, which was Boto3 client, matched both this range and that range. So both lines 2 and lines 5. But then the second pattern, which is the regex, only matched this range inside that first pattern. So this basically lets you see how the compositional logic inside the engine is working to filter down and finally reach, just a single result. But it can be really helpful if you're composing things and you're kind of like, well, should that actually have matched here or should it not have matched here? We've found this to be invaluable for some of our internal debugging. So the last thing, saving the best for last, is autofix. So here I'm returning to that example of the Golang server that was using TLS. So what we have here is I've specified it out fully rather than using a dot dot dot. I'm explicitly saying, yep, the first argument is always address, the second argument is always the function handler. And I'm using a fix key inside the YAML to use the exact same syntax that I used to specify the pattern to specify the fix. So in fact, this is not something that can be truly automatically fixed because, if you are actually serving over TLS, you need to have a certificate file, you need to have a key file. But these names come straight from the Golang documentation. So I can at least make a suggestion to the developer that says, hey, you can go check the Golang documentation to figure out what these variables should be. And I'm just going to reformat this function invocation to exactly what the correct output should look like. You can see I've preserved the use of the first variable there. The use of the second variable has become the fourth argument, which is the handler function. And then when I run the code, it's going to tell me that cert file and key file are undefined, but that's actually exactly what I want. That's the next step for the developer to go back and actually implement the fixed code. So in terms of what's on the roadmap, building more code equivalences into the engine such that, when you write something, Semgrep just sort of does the right thing under the hood automatically. Now that we have support for specifying them, it's much easier for us to basically say, hey, if you have an idea for an equivalence, you can prototype that really cheaply, and then it can just be added to the main engine if it's something that makes sense for everyone to benefit from. The type inference stuff is new. It's pretty awesome, but it's still new, so it needs more support to actually do type propagation throughout the file. Doing more constant propagation via data flow. So this already works on a number of languages. It works on any language that has a const keyword. But for instance, in Python, Python does not have a const keyword. Currently, we don't do a data flow analysis that will produce essentially inferred const values. So that's one of the things that's coming up. And then doing intra-file tainting is something that is also on the roadmap. Ajin has gotten some previews of that, and we've been working with him to develop it. And then more languages. So Ruby, TypeScript have been mentioned. And then the last thing that I'll tease, which is very late breaking, but really cool, is that we've been working on making it so that in the live editor, you can just highlight a snippet from the code, and it will show you a couple example patterns of varying granularity that would actually be the patterns which will match the code that you've highlighted. So that should be useful just in terms of, if you're trying to show this to some team members, but they're like, oh man, I don't want to learn any new syntax at all, even if it is simple. How simple can you get from being able to highlight the code and be like, hey, here are a couple queries that will match variations of exactly the snippet that you've just shown us. It's especially powerful when combined with the type inference capabilities, because that lets you get really specific and granular at the type level, which can be super, super helpful. So that was Semgrep. The TLDR, you probably knew most of this already, but match code patterns, be fast, support lots of languages, feel like grep as much as possible, but try to have those really powerful analysis features under the hood. And with that, I am open for questions.
Super, thanks, Isaac, and everyone feel free to unmute yourselves if you'd like to just save yourself the work of typing out the question.
Either way works for me.
Also, if you're not already a member, we would love to have you join our community Slack. I will actually just type in the shortcut link to get there. As Ajin and Isaac mentioned earlier, there's some nice activity going on. You can chat with other people who may be doing similar things that you have in mind.
Yeah, we also have been trying to tease experimental features for people inside the Slack room and get feedback. It's been invaluable for us. Clint, unfortunately, I can't show a demo of that. It is too late breaking. The question was, can I show a demo of generating pattern options from text? But hopefully at the next meetup, which maybe will be in person, fingers crossed. The COVID situation has made this feel all a bit more impersonal, so I miss being able to see people. So Ron was asked a question about what's returned when running against community modules at scale. Maybe you could expand on the question, Ron, if you don't mind. Are you thinking in terms of what the platform returns, or what have we found at a higher level? So the platform gives you, basically an interface that shows, hey, like you ran this configuration across this corpus of repos, which are frozen in time. And then you can drill down by repo or by rule and start triaging and labeling. Essentially, like it's sort of similar to Ajin's tool, except it's not really designed for somebody who's actually maintaining the application. It's designed more for a researcher or a bug hunter, and especially designed for someone who is interested in iterating on and improving the V0 of the rule. So, it will let you flag, hey, this is a true positive, this is a false positive. Then you can go back and see, oh, wow, actually this one rule, this check ID in particular, it just generates way too many false positives or false negatives. So we'll go back and tweak it. And then there's a scoring view as well. I might be able to pull that up if you give me a second. That will actually compute some stats on, hey, like what is the true positive? What is the false positive? What is the performance of the rule over time? There's also some experimental stuff that will mine the history of a repository. So I can actually show that real quick because I think it's pretty interesting. This is not yet available on platform. All right, let me switch back to the presentation. But here's a view of Apache Airflow. And what we see over time, these are all the checks that the Python check pack for Semgrep saw over time. And what we've got here is basically a one. This means that there's one finding of this check present at that git commit. In particular, of particular interest is this little range here. So this is a check to look and see, are you comparing a string with is in Python? So you can see here on 6th of July, 2018, there was a commit that suddenly there was a comparison with this is thing. And then actually just 4 days later, there is not. So if I click on this, we should expect to see hopefully a very small commit to indicate that this is actually a bug that's been fixed. And in fact, yes, it's referencing an issue, and it's just a tiny change that makes this Semgrep check go away. I don't have handy the view that shows you the scoring for the check, but this is something that, in addition to manually labeled data, we've been doing work on basically automatically inferring based on the history of the project. Oh, is this something that actually, like seems to result in bugs that get fixed inside the project? So if I scroll further back, you can see that there was another instance of this thing that ended on 21st of April and was present since 14th of June, earlier in the project's history. So currently the true positive data lives inside the platform database run, but you can directly log into the database to access it. And then Ajin, your question was about what the timeline is for source sync sanitizer to be in Semgrep. Right now, a lot of the program analysis resources are going towards the addition of new languages. Once new languages are in particular Ruby and TypeScript, I think when they land in July, we will get back to working on the source sync sanitizer work. So it's on hold a little bit for the time being. Yeah, thanks for the questions. Thanks so much for joining, folks. I know we're almost at time. Ajin, thanks so much to present and just share what you've been working on in our collaboration with the community. We've really enjoyed working with you and supporting you. It's an awesome collaboration.
Thanks, everyone. Thanks, Isaac. Thanks, Ajin, and thanks, everyone, for attending. And we will post a recording so you can watch it later, send to a friend, etc. And we'll tweet about it and link to it in the community Slack.
Thanks so much for hosting, Pablo. Really appreciate it.
Yep, no problem.
All right.
Have a good night, everyone. Thanks for joining.
Bye-bye, everyone.